Welcome everyone. In this session, we'll explore the concept of deep learning. Whether you have heard the term passed around in tech circles or are just curious about the buzz, this video aims to give you a solid understanding of what deep learning is and why it is such a big deal. By the end of this video, you'll know what deep learning is, how it fits into the broader world of artificial intelligence, why it's called deep learning. Is there a thing like shallow learning? How these deep layers help computers to recognize complex patterns in data without us explicitly telling them anything about the patterns inside the data. We'll also look at why deep learning can be mysterious and, not fully explainable, and what that means for AI development. To understand the concepts in this video, you do not need any technical or programming knowledge. Just bring in your curiosity. You may be seeing news that deep learning models are beating humans in standardized tests, or that it is beating people at different types of games. Underneath all the excitement, there's a very practical approach to teaching computers how to recognize patterns from data. Deep learning is simply a subset of machine learning, which in turn is the subset of a broader field called artificial intelligence. So think of deep learning as one specialized tool in the AI toolbox. To understand why we call it deep learning, let's consider a simpler version, often referred to as shallow learning. In shallow learning, you typically have one main layer or a very small number of layers that processes data and tries to make a prediction. For instance, you could have a single layer of mathematical operations that determine whether an email is spam or not. This single layer might do an okay job, like a basic spam filter that catches most obvious spam messages. However, there are many other real-world tasks which are far more complicated. Imagine trying to identify objects in an image. Is that a cat, a dog, a person, a tree, or things like that? A single layer model is going to struggle in this case because it cannot capture all the details in the image that are needed to make an accurate prediction. This is where multiple layers come in. When we talk about deep learning, we are referring to models where several layers are stacked on top of each other. Each layer transforms the data a little bit, passing its output to the next layer, which refines it further and sends it to the next layer. The more layers you have, the deeper the network, and hence the name deep learning. If you have watched the video, What is a Neural Network?, you'll understand that what's inside these layers is essentially a special arrangement of neurons. Even though it's called deep learning, keep in mind that these models are still processing numbers. If you have watched our video on what is an AI model, this should sound straightforward. A deep learning model has a set of parameters, often called weights, which are numbers that get adjusted during training. And it has an architecture which decides how information flows from one layer to the next. In fact, a deep learning model is often described as a series of mathematical equations. These equations are just arranged in multiple layers, making them deeper. But no matter how fancy it gets, ultimately the model receives numbers as input. And then it processes these numbers through these layers and layers of equations and then provides a prediction in the form of a number, which can then be predicted based on the problem that you're trying to solve. In traditional software, we hand code tools. For example, if we want to write a program, to detect spam. We can write rules like if the email, contains a word like free more than 5 times, then just mark it as spam. So essentially, we are effectively telling the computer with hand-coded rules what to look for, right? Deep learning flips this idea, right? There are no hand-coded rules. So instead of handcrafting these rules, like, it's like listing every possible shape that an image can contain, all possible shapes that, a cat's ears could be in, depending on which angle you're viewing it from, or anything crazy like that. So instead of doing something like that, or for example, spelling out all the grammatical rules associated with the English language, because you want the network to learn English, for example. So instead of hand coding rules like that, what we do here is just to flip it around. We give the deep learning model a huge amount of data, and the model figures out the patterns in the data by adjusting its internal weights. It does this by itself. This is why deep learning is considered more of a black box compared to traditional software. We don't always know which features the model is focusing on in each layer. The model decides for itself what's important to pay attention to. Deep learning can be mysterious because the learning process unfolds through millions or billions of these internal model parameters or weights that are unknown. Even the people who built these models can't always articulate why a model made a particular decision. It just seems to know based on the patterns that it has discovered in the data. You may be wondering how we can figure out the best numbers called model weights for all of these layers. The process is similar to how any neural network model is trained. When you have millions or billions of weights, you require special compute like GPUs, graphical processing units, and huge data sets in order to figure out what these unknown values are. If shallow models could learn these patterns, then why do we need deep ones? Think of shallow models like a single person trying to do all the tasks in an office. Answering phones, doing accounting, designing a website, managing inventory, etc. They might manage, but the quality is going to suffer and it doesn't scale because it's too much for one person to handle so much effectively. Deep learning is more like having a team of specialists. Each layer focuses on a particular aspect of the problem. One layer might specialize in detecting edges in an image. Another one may be able to recognize more complex shapes. Another one can put up all of this together, the relationship between them, to figure out if there is a cat. This layered approach often results in higher accuracy for complex tasks. This allows the model to build up an understanding of the data step by step. Deep learning's strength lies in its ability to learn complex patterns without human intervention. There are no hand-coded rules on what to focus on. The model figures this out by itself by adjusting its internal weights. However, this comes at the cost of explainability. In a shallow or a more traditional model, you can pinpoint that, this input goes through these, rules, and that's how that led to this output. While in a deep neural network with dozens of layers, it's very hard to track a final decision back to exactly why and what feature resulted in the model making that decision. In a deep model with dozens of layers, it's much harder to trace a decision back to a simple human-friendly explanation. This trade-off is a big area of research in AI as people are looking for making deep learning much more transparent. So deep learning is a specialized method within machine learning that uses multiple layers to process data. It's called deep because it stacks these layers, enabling the model to capture increasingly complex features. Ultimately, it's all about numbers, just at a very massive scale. A deep neural network is trained by throwing large amounts of data and a ton of compute also, allowing the model to learn patterns inside this data on its own. It's very powerful, but often not human explainable. It's like a black box that we can't always interpret. So there you have it. Deep learning may sound like magic, but at its core, it is a structured way of layering mathematical operations to automatically discover patterns in large datasets. We call it deep because of the many layers involved, each uncovering a progressively detailed feature. The amazing thing about this is it can learn anything, from edges and different complex patterns in an image to nuances of the grammar without us explicitly programming those rules. Thanks for watching, and I hope this makes deep learning a little less mysterious, even if it is a black box. Stay curious and see you next time.